In an orthogonal turning of a mild steel bar of 60 mm diameter on a lathe, a feed of 0.8 mm was used. A continuous chip of 1.4 mm thickness was removed at a rotational speed of 80 rpm of work. Calculate the chip thickness ratio, chip reduction ratio, and total length of the chip removed in 1 minute. Okay, here operation is orthogonal turning operation. So here metal cutting operation is orthogonal turning operation. So this is orthogonal turning operation, and here we have a mild steel bar of 60 mm diameter. So diameter of workpiece, diameter of mild steel bar is 60 mm. Okay, next and feed of 0.8 mm was used. Here feed F is equals to 0.8 mm. Here feed is 0.8 mm. The continuous chip of 1.4 mm thickness was removed. So chip thickness, here chip thickness T2 is equal to, let us say T2. So chip thickness T2 is equal to 1.4 mm. Chip thickness is 1.4 mm, and here you given feed. Feed means nothing but uncut chip thickness. Remember, feed means uncut chip thickness. Uncut chip thickness. So feed in the sense, feed means uncut chip thickness. So orthogonal cutting operation, okay na? Or some orthogonal turning operation. So feed and the meaning ఏంటంటే మనకి uncut chip thickness, okay na? So generally denote uncut chip thickness means T1. This is T1. So uncut chip thickness how much? 0.8 mm. So before operation, okay na? And after cutting process, chip thickness is actual chip thickness is 1.4 mm. Okay. And next, so you also given, I think, rotational speed. Rotational speed. So denoted by n. So how much you given rotational speed? So rotational speed also given. How much you given? So rotational speed 80 rpm. Given 80 rpm, 80 revolutions per minute. 80 revolutions per minute. Okay. So here we produce continuous chips. At the same time, rotational speed of 80 rpm of work. Calculate first question, chip thickness ratio. First one. So first we need chip thickness ratio. Chip thickness ratio. So chip thickness ratio denoted by R. So R means chip thickness ratio. So first we need chip thickness ratio. Okay. So what is the formula for R, chip thickness ratio? Chip thickness ratio is equal to uncut chip thickness by chip thickness. Uncut chip thickness by chip thickness. So this is the formula of chip thickness ratio. Okay, very simple problem. Uncut chip thickness. Uncut chip thickness means what? So we already discussed about feed. Okay, na? So uncut chip thickness is nothing but feed 0.8 mm. So actually here formula is T1 by T2. T1 by T2. Uncut chip thickness means T1. Chip thickness means T2. T1 by T2. So T1 how much? Here T1 is feed 0.8 mm by T2 1.4 mm chip thickness. So after machining process, this much thickness we have produced. So anyhow, 0.8 by 1.4. So we can write 0.8 by 1.4 as 8 by 14. 8 by 14. 0.8 by 1.4 means 8 by 14. So 2 4s are 2 7s are 4 by 7. If you simplify this, you will get 0.8 0.7, 0 point means you will get 40, 40 by 7, 7 5s are and 7 7s are, okay, 0.57. Therefore R is equal to how much? R is equal to, chip thickness ratio is equal to 0.57, 0.57. So chip thickness ratio R is equal to 0.57. And the next question is we have to find chip reduction ratio. Chip reduction ratio. Chip reduction ratio. So chip reduction ratio is generally denoted by K, small k. So chip reduction ratio K is equal to 1 by R. So what is R? 1 by R. What is R? R means chip thickness ratio. Here R means chip thickness ratio. So chip reduction ratio is a reciprocal of chip thickness ratio. Chip thickness ratio. Of course we have chip thickness ratio 0.57. So R is equal to how much? 0.57. So 1 by 0.57. So if you simplify, you will get 1 point. Here I got approximately 1 point. I got final answer 1.7544. So this is chip reduction ratio, value of chip reduction ratio. So length of the chip, length of the chip produced per minute. So next we have to find length of the chip produced per minute denoted by LC. So how to find LC? Okay, length of the chip produced per minute. It means length of the chip after cutting. So cutting tarvata length and chip length ento vachindi manaki. So remember, this is we are producing continuous chips. Okay. So in general, chip thickness ratio is equal to uncut chip thickness by chip thickness after cutting is also equal to LC by L. What is LC? Length of chip after cutting, length of chip after cutting per minute by L means what? Length of chip before cutting, length of chip before cutting per minute, so LC by L. So chip thickness ratio is also equal to LC by L. LC means length of the chip after cutting and L means length of the chip before cutting. So we have to find length of the chip after cutting. LC we want LC. Transpose L. LC is equal to R into L. What is the value of R? Chip thickness ratio. We have got 0.57 into L. We need L. So L means length of the chip before cutting. Length of the chip before cutting. So formula for L is pi dW NW. So what is dW? dW means diameter of workpiece. Mild steel bar, how much given? 60 mm into NW. NW means rotational speed. So rotational speed how much given? 80 rpm. Okay. Now multiply. Pi into 60 into 80. 60 into 80, 4800 into pi. If you multiply, you will get around 15079.7 m. This is the length of the chip before cutting per minute. This is our estimation, 15079.7 mm. We want to produce this much chip length. So next we need LC here. So LC is equals to now R into L, 0.57 into L means how much? 15,079.7 mm. If you multiply, then you will get length of the chip after cutting. Approximately you will get 8595.4 mm. This is the length of the chip after cutting per minute. Okay.